So I'm very lucky to be working alongside a team at IBM on the hypertaste sensor, which is going to be deployed on a automated vessel going across the Atlantic. This is a very exciting project. The sensor itself is a novel type of sensor, but it's essentially using the principle of electrodes, of picking up a current of electricity based on the presence of certain elements. This is a laboratory pH electrode. Okay, so you can see that it's not incredibly complicated in terms of the electronics and things around it, but these electrodes can be very sensitive and very selective if you control the medium of the membrane that's around the electrode and the chemistry. So as you can see, this is much smaller than an instrument like this mass spectrometer behind me. So if the hypertaste is using the same type of electrode, just like this pH electrode, but it has a whole series of electrodes involved in the sensor, and it's very small, compact, can go on an automated vehicle such as the Mayflower. So we need to understand the elements present in seawater. Many of them act as nutrients in the ocean. So elements such as nitrogen take part in the building of proteins in living cells. Some elements are toxins. So for example, something like mercury or cadmium, lead, let's say, those are all elements that you don't really want in high concentrations in the ocean. So we have a sort of role of monitoring those toxic elements to make sure those aren't in high concentrations. Many of the elements also act as tracers. So in order to work out how the oceans circulate, it's useful to actually have elemental tracers that tell us where water has been. As a marine chemist, I have to go out to sea and collect samples. So as you can imagine, going out to remote areas of the ocean, collecting seawater and bringing it back to a lab, then doing analysis, is a very time-consuming and costly way of doing things. At the moment, we have to do that to ensure the quality of the data is of a very high standard if we're reporting data that goes into ocean models and informing the public and society. So we take our jobs very seriously, and that means we want to do the best job we can. This obviously comes with a cost. Doing the analysis of one sample, all the sampling, all the travel, the people's time, we could be talking around £100 per sample to do that analysis. Luckily, this instrument, it will measure lots of elements at the same time. It's one solution to the sort of effort and time and money that goes into collecting samples for marine chemistry is to consider using autonomous vehicles, either gliders or they could be ships. Using those really has major advantages. It means that you can go to areas of the ocean that would be very difficult to go to on an ordinary ship. You can also potentially have these vessels out for much longer periods of time than we would be able to go out on a ship.